All right, welcome everybody. This is 12.1 Central and Inscribed Angles. So this unit for Unit 12 is all about circles and the angles that can be made by like lines inside of them, like a really basic explanation of what we're doing. Okay, so first off, we're going to come and talk about some vocab. Some of the stuff you've talked about before, maybe sometimes not. Okay, so first off, we got a circle. So a circle is a set of all points that have the same distance from the center. So if we had this circle and you made like a radius out to like infinite amount of places, okay, and put points on all of those, that would eventually make a filled-in circle. Okay, so that's kind of like the definition of a circle. How we would like write down this circle, so maybe we have different circles and we want to specifically say like which circle. How we write that is we'd do like a little circle with a point in the center, and then we would write down whatever its letter is. So this is like circle C. So we label it based off of its center. All right, next we have is a chord. So this isn't like a musical chord. This is a line segment whose ends are on the circle or on the circumference. So if we look at this example, it looks like we have two chords. One is chord AF, and we put a line on top of it, and the other would be BE. In the order of those, if you did EB, that's fine too. Okay, so those are chords. Next we have, I think, is the diameter. So the diameter is a special chord that intersects the center of the circle. So we have one diameter here, and that would be BE. Okay, and then the last thing is the radius. So the radius is a line segment whose endpoints are the center of the circle and a point on the circle. So I think you probably know what a radius is. So this example would be like line segment CD. All right. We also have two others. If you can find that there, it's kind of tricky. We also have one that's CB and CE. So there are three radii that are written here. So we could also do CB and CE. All right, so why don't you pause and come up with, we have another example. I want you to write down the four things listed here. All right, so hopefully you gave that a try. If you have not, give that a try. So the first thing is we want to label the circle. So that would be circle, L, radius. So there's 5 radii that you could use. So I'm just going to choose GL just because it's closest. Okay, but we could also do, HL or IL or JL or KL. Again, the order of those, if you started with L and then do K, that's fine too. Okay, and then a chord, looks like we have 2 chords. We could do HI, and we could also use GJ. And then the diameter is GJ. It's a special chord that goes through the center. All right, so there's just some vocab. We'll be talking about that through like problems. So you have the vocab in order to talk about it. All right, so we're talking about 2 types of angles today. We're going to talk about central angles and another type of angle that's called inscribed angles. Okay, so first off is a central angle. A central angle is an angle at the center of the circle. Okay, and its endpoints are on the circumference. So here would be a great example of a central angle. We have our center of our circle, and we have 2 radii that come out, and those 2 radii make an angle, and that's the central angle. Okay, so probably should put a T there. All right, and with a circle, we also have something called, gosh, the word just, an arc. Okay, we have an arc. All right, so there is a relationship. If you have a central angle, how is it related to the arc? So an arc is also a measurement, it's also an angle. So if we have a central angle, let's maybe say that kind of looks like, I don't know, maybe 100 degrees. So if the central angle is 100 degrees, then the arc is also 100 degrees. So they are the same, and that's kind of like the rule here is if we have a central angle, it is equal to the arc. All right, so keep that in mind. Let's maybe put a star on that, box it, something that's important that you'll need to have that memorized so that you could do some of these problems. Okay, there are different types of arcs. There are major arcs, minor arcs, major arcs, and semicircles. So minor arcs is when the arc is less than 180 degrees. Major arcs are where it's more than 180 degrees, and then we have semicircles where the arc is 180 degrees exactly. Okay, so let's talk about minor arcs. So if the central angle, so again we have a central angle because its vertex is at the center of the circle. That's the name, central angle. All right, what would be its arc? Well, here its arc is the same as its angle, so this would be, 110 degrees. And how do we name it? Just kind of like we talked about, like the circle and how to name like the radius or the diameter, the chords, these line segments. How do we write it down for like an arc? So this arc would be arc AC, and to be able to mark it as an arc, we do an arc on top of it. So it's like part of the circle, okay? And here we said that the arc degree is 110 degrees. Major arc, okay, is what's greater than 180. So I've had people in the class say, ooh, how are we going to label that? Well, sometimes people say DF, okay? But if it's a major arc, you'll always have, you'll have 3 letters to define it. If we just wrote DF like this, then that's telling us that it's a minor arc. If it's telling us it's a major arc, we have to use 3 letters to define it. So we would maybe start at D, and then we'd go to E and end at F. Okay? If there's another point here, maybe an F, we only need 3 points to define a major arc. So we would still maybe keep it as DEF. So I've had people ask that on the homework. They got confused because F wasn't part of the answer or whatever, what's being asked for, and so they were all confused. So I'll give another example when we get to the word problem, okay? The problems. All right, what would be the measure of the arc here? Well, we know that angles, and this is maybe something we should put a little star here, that a circle is equal to 360 degrees. So they tell us that the minor arc is 60, so what would the major arc have to be? Well, it would have to be 360 minus 60, so we'd get 300 degrees. Okay? All right, and then semicircles, you probably heard about semicircles before, and we know that the arc is 180 degrees. And we'll use that a lot. This is kind of probably the one that's most important for today, is being able to realize that we have a diameter and that we know that the angles within that semicircle. So like if we had something like this, and this was maybe 100, then you would be able to find what this is because we know that it adds up to 180, okay? So that's just kind of like what we're going to be coming up to in just a little bit. So anyways, we want to write down this semicircle. Again, if a semicircle, you're going to need to write down 3 letters because we could also define the other semicircle that's not shaded by blue. So here we would do like JKL, all right? So we can't just do JL, because we wouldn't know which side of the semicircle. All right, so we could write that one, or we could also done JML. Okay, so those are those three types of arcs. Keep those in mind. Again, we're talking about semicircles the most today, and then we'll talk about major arcs and minor arcs next time. All right, so let's go to our next slide. We're going to maybe skip 2. I don't think it's as important. It's more like what number 3 is. So this is what the homework's going to look more like. Okay. The thing about this lesson, and the reason why I feel like this is a little trickier than the next 3 lessons, is that they're all a little bit different. You kind of have to glean the information that you already know in order to solve the problem. And it's not always the same. You can't just follow the same steps every time, kind of like we did with trig. So give yourself some time to do these problems. And as you practice, it'll start going a little quicker for you, I bet. All right, so let's start with something that's a little simple. We have the angle. They want us to know what is the arc. Okay, well, we just talked about that the angle, a central angle, is the same as the arc. So this is 112 degrees. So that one's not too bad. Most of the problems will be more like 2 steps in order to solve the problem. Okay, so maybe something like this. I guess this is still 1 step. Okay, but what do we know in order to solve this problem? Well, first off, maybe we should figure out what's being asked. So they're asking for angle VWU. So that's the angle made by these 2 lines. So we're looking for that angle. Okay. Also, we can notice that this is a diameter, which means that the whole semicircle is 180. So what does this have to be? Well, we know the semicircle is 180, and we could subtract the 61 that we have over here. And so we'd end up getting 119 degrees. Okay. Again, the arc is the same as the angle. So, I mean, if you wanted to, you could put x up here instead and use that to solve. Okay. All right, C. Here they're looking for the arc FDE. So we start at F, we go to D, and then to E. So we're looking for this big, long arc. Okay. So again, we have a diameter, which means that this is 180 degrees. We have this other angle that's 95, and that's what's being asked, is the combination of those 2. So 180 plus 95 would give us I think 75 degrees. All right, so feel free to pause and give a try on any of these. I think it will help you the best if you'll try it and then go over the lesson or the problem with me. All right, so here we're asked for FHE. So FHE is, and it's an angle. So we're looking for that angle. So this time we have like expressions. And in order to find the angle, we're going to need to figure out what x is. So we need to take those 2 expressions and see how are they related. So just like when we did A, we know that the angle is the same as the arc. So we know that 11x minus 1 has got to be equal to 9x plus 11. And then we could solve. So we could add 1 to both sides. I would probably subtract 9x from both sides, because we're going to get x by itself. And we'd get 2x equals 12. And then we'll divide both sides by 2 to get x equals 6. So we're not done because we have to find the angle, but we'll plug that in. We'd get 11 times 6, so that's 66, minus 1, so that would be 65 degrees. Okay. All right, here is E. Here's another example. I don't know that we'll necessarily solve it all the way, but they're asking for arc LM. So we're looking for this. But before we could find that, we got to find x. So again, we have two expressions. How are they related? Okay. Well, if you remember when we talked about triangle similarity, we talked about vertical angles. So those two are vertical angles, and we know that they're congruent, they're equal to each other. So we'll just set them equal to each other. Okay, and then we could solve just like we did before. I think we could subtract 11x, and we could add 4 to both sides. So that would cancel, and we'd get x equals 7. We'd plug it in here. 7 times 12, I think that's 84, and then we'd minus 4, so that'd be 80. Okay, so I think that's right. If not, let me know. Okay, I'm pretty sure that's right. All right, so again, it's the same sort of thing. We just need to find the relationship between those two expressions. They could be equal to each other. We could have something where maybe they add to 180, kind of like we had something like this. Okay, maybe we would have like an expression for this one and an expression for this one, and would add them together to give us 180. Or we could have something like this. So again, we have expressions, we have x's we need to solve for. So how does this angle, and this angle relate to each other? Okay. All right, so basically we have the information for all the angles. So what do all of the angles of a circle do? Well, they add to 360. So we could do 360 equals 130 plus a negative 21x plus x plus 130. Okay, so again, same sort of thing. We could combine like terms, get x by itself. I'll leave that for you if you want to, but I think you end up getting x equals negative 5. Would plug that in because that's what they're asking for is IH, arc IH, and we'd get negative 5 plus 130 gives you 125. Okay, you could also plug this in here and figure out all of their angles and make sure that they give you 360 in case you made some sort of mistake with your algebra for your equation. Okay, so these are kind of the things that you want to maybe look for. We want to maybe look for vertical angles. We could look for, if you have every angle, we know that circles add to 360. If you have a diameter, you may want to think we have a semicircle. Oops, that's not how you spell that. Semicircle adds to 180. And we also maybe want to remember that a central angle is equal to its arc. So those are some things that will help you as you go along. Okay. All right, so there's another type of angle. The last that we're going to talk about is called an inscribed angle. Okay, it is an angle that's formed by two chords. So we have chord AB and chord CB, and they share a common endpoint. Okay, and that angle here is the inscribed angle. All right, so you can see it this way. You could also see it as like a triangle. You could actually see a triangle there. So you could see it both ways. But let's see if there's some sort of rule. My guess is it's not going to be the same as the central angle. So with the central angle, the arc is equal to the angle. So let's see if we can figure out how do we come up with this rule. So this is what I did in class, is we connected a chord that goes through the center, and we're just going to focus on half of this this side of the the inscribed angle, okay? So we could also add another radii right here, or radius here, okay? And that gives us a triangle. And we know that the radius for both of these are the same. So what type of triangle is that? Well, that's an isosceles, okay? And what we did is we just came up with some sort of angle that we could, what looks plausible, okay? Because this rule is going to apply for any example. So we could use variables instead, but I think it's easier just to kind of think of it as an example with like maybe the angle here being 10. All right, so if that's 10, what else do we know about isosceles triangles? Well, we know they have two congruent angles as well. And those congruent angles are the ones that are across from those congruent sides. So this angle must also be 10 degrees. Okay, and we know that triangles add to 180, so this angle has to be 160 degrees. All right, and then here we have like a semicircle, right? So what does this part of that semicircle have to be? Well, it would have to be 20 degrees. Ooh, we just found a central angle. So this right here is a central angle. So what do we know about its arc? Well, its arc is also 20 degrees. So what is the relationship between the inscribed angle and its arc? Well, it's doubled, okay? And we could do the same for the other side of this graph. We could put, 10 here, and we could draw this same sort of thing. This would be 10, and this could be 20, and then this would be 20. And again, if we added those, the inscribed angle would be 20, and if we add the arcs, that would give us 40. So again, we have this rule, is that 2 times the inscribed angle is equal to the arc. So if I gave you something like, I'll leave that there, I was going to erase it. So if we had the inscribed angle as, maybe I'll just draw another triangle. If we had something like this, if this was 10, then what would we know about the arc? Well, then it would be 20, okay? If the arc was 30, what would we know about its angle? We'd have to kind of go the opposite. We'd do half of it would give us the angle, okay? So if you wanted to rewrite it like this, you could also say that 1/2 of the arc is equal to the inscribed angle. Okay, so we could divide both sides by 2, and we would get that same thing. Okay, so that's kind of what we want to look at. Maybe put a star on that. So keep that in mind. Like I said, this is another way you could see it. Let's see if we can figure this one out without any numbers. Let's see if we can figure out what this angle must be. So we know that we have a semicircle. So this is kind of like the special cases when we have a semicircle. We have a diameter. That means that this has to be 180 degrees. So this would be its arc. And then what would be its angle? Well, it would be half of that. So this actually needs to be a right triangle. It would be a 90 degrees. So the cool thing about that is if you ever have like a diameter, it doesn't matter where this is, you'll always have a right triangle, okay? So if you're ever trying to draw a right triangle, you could always do a circle and do something like that, draw its diameter and do something like that, okay? But again, this isn't anything special. It's not in a special rule or anything. It's just like a special case where we have the diameter, okay? One thing I should probably mention is that we should never assume anything. So if we look at A, don't ever try and connect those and assume that it's a diameter, okay? If it is a diameter, they would have drawn it, all right? You should never need to draw extra lines. And usually when people do that, it gets more complicated and they're not looking for what what is going to actually help them. Okay, so let's do a couple examples like that. Okay, so they want us to measure the missing arc or inscribed angle. So again, this then isn't too bad. How is this angle related to its arc? Well, we know that it's an inscribed angle, so the angle has to be half of the arc. So 174 divided by 2, and that would give you, I think, yes, I'm trying to do it in my head. I think it's 87 degrees. Okay, maybe I should get my calculator out. All right, so just keep that that rule is the angle is half of the arc, or the arc is 2 times the angle. All right, so next off, we need to find this arc. Okay, so there are different ways to do these problems. Sometimes some are easier than others. Okay, so just keep that in mind. I'll show you an example here. There's 2 ways you could go about doing this. Here is our angle. So we could look and say, well, where is its arc? Well, its arc is here. And how is it related to the angle? Well, the arc is 2 times, so 2 times 50. So it would be 100. We also notice here we have a diameter, which means that the whole semicircle is 180. So how could we find the question mark? Well, we could just do 180 minus 100. Okay, so that is an option. I think that's probably the quickest. All right, sometimes people kind of go the opposite direction, and sometimes I think that's very beneficial to kind of say, well, this is what I need, and then kind of go backwards, which means we would need to find this angle. All right, so we know that this is 180, so we know that the inscribed angle here would be 90 degrees. Okay, and means that this has to be 40. And then we can double it to give us 80. So we could do something like that too. So there's different ways to do it, but figure out what works best for you and stick with it. Okay, here's another example. We have an angle, which means its arc is 2 times that. So that would be 168 degrees. We have this arc, which is 60, and we need to find this missing arc. Again, we know they add up to 360, so you could do 360 minus 60 minus 168. Okay, and here I will need my calculator. I don't remember what that one is. So 360 minus 60 minus 168. And I got 132. So let me double check. Okay, yeah, 132 degrees. All right, here's another example. So sometimes, and this is the thing that sometimes people get confused, is sometimes they give us extra information. Maybe we don't need all of those lines. Okay. One thing I like to do is I start with the angle, or what we're looking for, which means we need to find this arc. I feel like sometimes that helps a lot, because now we can kind of realize that this is a semicircle. So we just need to do 180 minus 96. So 180 minus 96 is 84 degrees. And then we know that the arc is related to the angle. We just divide it by 2. So 84 divided by 2 is 42. Okay. All right, looks like we have 2 more. Pause if you'd like, give it a try. So here we have, this is this angle, x plus 19. That's all that we could fit in there. And then this would be its arc. So they give you an expression for the angle, they give you an expression for the arc. How are they related? Well, we know that 2 times the angle, so 2 times x plus 19 is equal to 4x plus 16. We can use the distributive property. We can get x on one side, and we can get the constant on the other side, and we'd get 2x on that side, and then 38 minus 16 gives us 22. And then we can just divide both sides by 2. So x is equal to 11. So they're asking for the angle ZXY. So ZXY. Again, if you're doing like an angle, it's always like the vertex is the center or the middle letter, if that helps. So then we just plug that 11 in here. So 11 plus 19 is equal to 30. Again, you could plug it into here. You probably should know what it should be. It should give us 60, right? Because it doubles it. And we get 4 times 11, which is 44, plus 16 gives us 60. All right, last one. So this one's a little more, it takes a little bit more work, but how are these related? Okay, so the first thing we're going to need to find x. If I ever give you expressions, we need to know how they're related. Okay, well, we know it's a semicircle, so they add to 180 is equal to 3x plus 1 plus 21x plus 9. So combine like terms, looks like we'd get 34x, and we combine the constants, gives us plus 10. So I think if we subtract 10, we get 170, and then we could divide both sides by 34. So we get x equals 5. So they're asking for this angle, okay, angle MKL. So we'd need to maybe figure out what the arc is first. So we'd plug that in here. We'd get 110 plus 9, so 114. And then we'd divide it by 2, and we would get 57. Okay, so feel free to stop in. I know this is a little much, and if you have questions or want to go over some problems on the notes or on the homework, feel free. Stop by before or after school, and we can talk about it. If you're not, if there's lots of little things. So yeah, just please make sure you come in and get some help if you need to. All right, we'll see ya.